Section 9.6 is about measures of chords, tangents, and secants. So in the last section, we were still talking about chords, tangents, and secants, but we were talking about angle measures. So now we're going to be talking about the measures of the line segments themselves. Okay, so if you have intersecting chords, so if you have two line segments intersecting inside the circle, like you see in this top picture here, then the rule is if you multiply A times B, helps if I turn my pen on. If you multiply A times B, that's going to equal C times D. So A times B equals C times D. Or the segment times the segment equals the other segment times the other segment. Hey, if you have two secants, hey, I'm going to start here. The little acronym that you're going to use is something called WHO. What does that mean? It means we're going to multiply the whole secant times the outside of the secant. That's where WHO whole outside. WHO whole outside. Okay, so the whole secant, the whole top secant, the length of that, if I add A and B together, that's going to give me the whole secant. So that's where that A times B comes from. And then the part that's outside of the circle is part A, and that's where that A comes from. So this is technically the whole, and this is technically the outside. Okay, order that you multiply in doesn't matter. Same thing on the bottom one. If I want the length of that whole secant, again, if I take the measure of part C and add it to part D, that would give me the whole secant. So that's why I'm adding C plus D there. And the part that's on the outside of that circle is C. So that's where we're multiplying by C on the outside. So that C plus D, again, is technically the whole part of the secant, and the C on the outside is the outside of the secant. And if you have a secant and a tangent, it's basically the same exact thing that we just did, with the exception of the fact that when you try to do WHO for this one, the whole piece and the outside piece are both A. So A times A would be A squared. And then if I apply the same concept that I did just in that right above, if I want the entire length of that secant, I would have to add B plus C together. And then again, if I multiply that by the outside, that would be B. Okay, or really what that means, that should be a square there. That means that the tangent square, that's what the T stands for, tangent. So the tangent square equals the whole times the outside. And again, if you wanted to look at it like WHO, at the top part here, again, the whole and the outside are the same thing. It would be A times A, or A squared, or again, your tangent squared. So your tangent squared is going to equal your whole segment times your outside segment. So let's take a look at some examples here. So if AE is 12 and EC is 2 and BE is 3, we want to find ED. So again, these are my chords. They're intersecting inside the circle. That means segment times segment is going to equal segment times segment. Or 3 times X is going to equal 12 times 2. 12 times 2 is 24, so 3x is going to equal 24. Divide both sides by 3, and x is going to equal 8. Okay, it's as simple as that. For the second problem here, AE is 7, EC is 8, and EB is 1 more than ED, and we want to find ED. So I'm comparing EB to ED, so whatever you're comparing to is going to be X, so ED is going to be X, and EB is 1 more than that. So 1 more than X, we're just going to take X and add 1 to it. So now again, when I multiply those together, I'm going to have X times the entire quantity of X plus 1, and then I'll have 7 times 8. So two things that I'm going to do here. I'm going to distribute the x on this left-hand side. So x times x is x squared, and 1 times x is x. And on the right, 7 times 8 will give me an answer of 56. Again, this has rarely been coming up, but this is going to take us back to algebra. We have a quadratic here. I know it's a quadratic because I have the squared, which means I'm going to have to end up factoring this. To factor this, it needs to be set equal to 0. So that's going to be my first step. So I'm going to subtract 56 from both sides. There are no like terms on that left-hand side, so I'm going to write it as a trinomial. X squared plus x minus 56 equals 0. So now to solve this, we have to factor it. To factor a trinomial, again, this is when you are looking for two things that multiply to the last term. So multiply to a negative 56 and add to a positive 1. So take a second, think about it, two numbers, and again, just be careful of your sign. They have to multiply to a negative 56 and add to a positive 1. How about a positive 8 and a negative 7? Positive 8 times negative 7 would be a negative 56. And now if I add them together, positive 8 plus negative 7 would be a positive 1. And that's exactly what I want. So when I factor this, this is going to factor into two binomials. Again, first thing is always what times itself gives you that x squared. And the second thing going in there, and each one of those are the two numbers that we found, the positive 8 and the negative 7. Okay, so now that's factored. So now to solve that, we're going to set each factor equal to 0 and solve. So on the left one, we'll subtract 8 from both sides, and x is going to equal a negative 8. And on the other one, we're going to add 7 to both sides, and we'll have positive 7. Okay, again, can't have any negative numbers here. If you're talking about the measure of a segment can't be negative 8 units long. So we're going to ditch the negative answer, which means your only viable answer here is going to be 7. For number 3, we have a tangent and a secant. Okay, so we want to find x to the nearest 10th. So again, this is the third formula down that we had talked about, the secant and the tangent. So again, if you want to look at it as whoa, so it's consistent, whole versus the outer, whole versus the outer. The whole and the outer for the tangent are both x. So it's going to be x times x. On the other side, the whole, add those two together. The whole segment is 12. The outer segment is that 5. So we'll have 12 times 5. So x times x is going to give me x squared, and 12 times 5 is 60. Okay, this says to the nearest 10th. Opposite of squaring something is taking the square root. So we're chucking the square root of 60 into the calculator. And again, one spot after the decimal. So the length of x is going to be 7.7 to the nearest 10th. Okay, for number 4, PC is 12, BA is 10, and we want to find PB. Okay, so again, you have a tangent and a secant just like we did above. So again, if you want to be consistent, we're going to do whole times the outer, whole times the outer. So let's talk about the tangent first. The whole tangent is 12, and the outer piece of the tangent is also 12. So we're going to have 12 times 12 on one side. Okay, and on the other side, the whole secant, just like up here, we added 7 plus 5. Here I'm adding x plus 10. That's the whole secant. And then the outer part of the secant is x. So I'm going to have x times x plus 10. So again, when I go to solve this, this is going to solve. Again, it's going to end up being a factoring question, just like the one above. First thing I'll do on the left, 12 times 12 is 144. And on the right, we're going to distribute that x through. X times x is x squared. X times 10 is 10x. So again, I'm going to end up having to factor this. In order to factor it, it needs to be set equal to 0. So I'm going to subtract 144 from both sides. Those will cancel, leaving me with 0. Again, on the right-hand side, there is nothing that you can combine. So it's just going to stay as x squared plus 10x minus 144. Okay, this one's a little tough, but again, it's a trinomial, so you're just like we did above, you're looking for two things that multiply to a negative 144 and at the same time add to a positive 10. If you want to think about it, just pause the video. I'm going to tell you what they are though. The two numbers that multiply to a negative 144 and add to a positive 10 are going to be a positive 18 and a negative 8. When you multiply them together, it's going to give you an answer of negative 144. And when you add them together, it's going to equal a positive 10. And that's exactly what I want. So this is going to factor into x plus 18 times x minus 8. And that's going to equal 0. Again, we'll set each factor equal to 0. Subtract 18 from both sides. And x is going to equal a negative 18. Add 8 to both sides, and x is going to equal a positive 8. Again, if x is representing the length of a line segment, you can't have a negative length, which means that your only answer here is going to be a positive 8. Okay, for 5, we have two secants. So this is the true whoa. Okay, whole versus the outer, whole versus the outer. So we'll do this top one first. So for the whole one, if I add 19 plus 8, that's going to give me 27 for the whole. And my outer piece there is going to be 8. So we're going to have 27 times 8 on one side. And for our other segment, our whole is going to be x plus 9. And the outer part of that is going to be 9. So we're going to have 9 times x plus 9. First thing I'll do is multiply 27 times 8. That will give me an answer of 216. And on the right, we're going to distribute that 9. 9 times x is 9x, and 9 times 9 is 81. The opposite of adding 81 is subtracting 81. And you'll have 135 equals 9x. And then the opposite of multiplying by 9 is to divide by 9. And when you divide by 9, you should get an answer of 15 there. So x is going to be 15. Again, just go back, make sure you found what they were looking for. They only asked you to find x. You found it. You're done. Okay. So for number 6, we want to find x in simplest radical form. So again, I have a tangent and a secant. Again, I always think it's just easier to stay consistent with the whoa. Okay, and again, when you're talking about a tangent, the whole tangent and the outer tangent are both the same. It's x times x. On the other side, the whole entire secant, 9 plus 4 is 13. The outer portion of that, the part that's on the outside of the circle, is 4. X times x is x squared. 13 times 4 is going to give me an answer of 52. Okay, and now we just need to be careful. This says in simplest radical form. So again, simplest radical form, you're looking for the biggest perfect square that's going to end up being a factor of 52. Okay, first of all, the opposite of squaring something is taking the square root. So let's do that first. So far I have the square root of 52. Again, I can't chuck that into the calculator because they want it in simplest radical form. So again, just like in an earlier video, you are looking for the biggest perfect square. That, and again, 1 is never going to help you. That's a factor of 52. Okay, and right away, if you try 4, it's going to work. Okay, so 4 times what would give you 52? Take 52, divide it by 4. You're going to get an answer of 13. So radical 52 is going to break up into radical 4 times radical 13. But again, I know what the square root of 13 is. I know what the square root of 4 is. The square root of 4 is 2. And I don't know what the square root of 13 is, and we're just going to tack that on. So in simplest radical form, that's going to be 2 radical 13.